In this video, we will talk about summarizing and displaying single categorical variables. We'll talk about issues involved in producing data for a single categorical variable. We'll look ahead a bit to inference for a single categorical variable. And we'll give more details about displays and summaries. Remember, there are four stages of statistics: data production, displaying and summarizing, probability, and statistical inference. We will focus on displaying and summarizing in this lecture, and our focus will be on a single categorical variable. For single categorical variables, we will often use pie charts and bar graphs to display summaries of our data. Numerically, those summaries will be given as one of these: a count, a percentage, or a proportion. Let's cover a couple of definitions and some notation. We will use the term statistic, which is separate from the science overall of statistics, to refer to a number that summarizes a sample. Parameter will be the corresponding number for when we are talking about a population. For notation, we will use a p with a little hat on top of it, which we'll call p hat, to represent sample proportions, that is, statistics. This corresponding parameter will be noted with just a p. The easy way to remember the relationship between statistics and parameters and samples and populations is that both statistic and sample start with an S. Both parameter and population start with a P. Let's look at a few issues. Let's say that 246 out of 446 students taking statistics at a certain university had eaten breakfast on the day a survey was administered. Are Intro to Stat students representative of all students at that university? And would they respond to this particular question without bias? Whether this sample is representative depends on a few things. As long as the statistics classes are being offered at representative times, both morning, afternoon, and evening, again, this is a big university, and that class years are represented equally, first year, sophomore, junior, senior, etc., then yes, this group is probably representative of the population as a whole. As to this question, since there's nothing sensitive about it, I would expect users, folks taking this survey, to be truthful in their responses. Let's look at a couple of other issues involved in this same situation. First, how would we display and summarize the information we have gathered from our survey? Second, can we conclude that a majority of all the students at this university eat breakfast? To the first question, because this is a single categorical variable with two options, the best way to display the information would be with a pie chart. There would certainly be nothing wrong with using a bar chart in this case too, but as long as the number of responses, number of possible responses is pretty low, a pie chart is a pretty good idea. Ultimately though, it's a matter of preference for the person choosing how to display things. Here's a look at what the pie chart for this situation looks like. Remember, in a pie chart, the proportion of the total area given over to each response is equal to the percentage or the proportion of people who gave that response. Since 44.8% of respondents said they did not eat breakfast, that means that 44.8% of the area in the pie belongs to no. How would we summarize this information? Again, since this is a single categorical variable, we have three options: count, percentage, and proportion. Here are all three. To the last question, can we conclude that a majority of all students at the university eat breakfast? Well, it's certainly true that a majority of the students in our survey eat breakfast. But we don't yet have the techniques to make that final claim that a majority of students overall eat breakfast. In fact, this is an example of statistical inference. We'll cover this later on in the term. Let's explore how to use Microsoft Excel to create a pie chart. First, I've opened the student survey data spreadsheet that you can download from Moodle. In the spreadsheet, you'll find the data from the survey that was given by the authors of the textbook at her university. If you look around, you see the course number is Math 200, and there are just a whole bunch of questions that were asked on this survey. The one we're interested in, we can scroll all the way over to column AG, which is where we will find breakfast. I think it's easiest to work with these data sets kind of in isolation. So what I'm going to do is click on the AG at the top to select the entire column. See how the entire column is shaded, not just an individual cell like it is here if I were to click inside the spreadsheet. I'm going to click on the column header, AG, and then I will click copy. To isolate this set of data, down at the bottom here I'll click plus to add a new sheet, which opens up a nice blank sheet for us to work with, and then I'll click paste. Now we have all of our breakfast data in one place. In the Insert menu, you see a little picture of a pie chart here. It's what you'd like to use maybe, but we can't use it until we get the counts of our data. The easiest way to get a count for our data is to use a pivot table. So the next thing I'll do is click on Pivot Table. It asks me to choose the data that I want to analyze. It already has it highlighted here, but I wanted to make sure that you understand how to change this if needed. So to get the data I want, I'm going to click on the little box here at the end, which minimizes the dialog box and allows me to click in the background. So what I'm going to do is click on the top cell that I'm interested in. I'm holding down the button and I'm dragging down, and I want to collect all of this data, so we need to go down quite a ways. I'm going to keep going until we get to the bottom. There are 440 something respondents, so we're getting there. There we go. 447 is the bottom row. So I've got those selected, and now I'll click the button at the end of the row here to open this back up. Next, it asks me where I want the pivot table to be placed. You can choose a new worksheet, which will automatically open a new sheet afterwards, but I usually use an existing worksheet, and it asks me for a location. Again, I'll click the box at the end, and I'll select a cell over here to the right somewhere. Finally, I'll click OK. And we have our pivot table. There's not a whole lot here yet. But over here on the right, you'll see a little box that says Pivot Table Fields. Breakfast is already there. It's time to tell the pivot table how to fill itself out. What I want on the rows here are the possible responses for breakfast. So I will click on breakfast here, and I will drag it over to the rows. And you see now it says breakfast, no, yes, and blank. Now I want to see the numbers for each of those possibilities over here to the side where it says values. So again, I'm going to take breakfast and drag it over to the values. And there we have our counts. This option for blank we don't need. So I'm going to click on the little arrow next to breakfast, and I'm going to uncheck the blank option and click OK. And now we have our table. Now to create our pie chart, back to the Insert tab, I'm going to click on the charts, and I want a 2D pie chart. There's not a whole lot going on here yet. Up at the top we need to select the data. So, chart data range. Let me click the little box so I can click behind here and select. And I'm going to take in these 6 cells and click OK. And there's our chart. It might be nice if we had the actual counts displayed on the chart. You notice if you hover your mouse over each segment, it'll tell you the count and the proportion, but it won't by default display it. To get that to happen, if you right-click on the chart, like on one of the wedges of the pie, and go to Add Data Labels, select Add Data Labels, and you'll see the counts appear right there in the chart. If you want to change it so that it's not just the count, you can right-click on the label, click Format Data Labels, and here we can choose the series name, the category name, the value, the percentage, the leader lines. I'm not sure what that is. We probably don't need that. But let's do category name, value, and percentage. And you can see how all of those now appear inside our chart. If we want it bigger, all we have to do is click and drag in one of the little grabbers on the corners, make it bigger, and we have our pie chart. Returning back to the definitions we saw earlier, again in this situation of the breakfast survey, is the 246 over 446, the 0.55, a statistic or a parameter? And what will we use to denote it? Is the proportion of all students eating breakfast a statistic or a parameter? And how do we denote that? Because the 246 came from a sample, it is a statistic. And it's a proportion, so it's p hat. The proportion of all students eating breakfast is coming out of our population, so it's a parameter. Parameters are denoted with just a p. Let's look at a different example. The location by state for all 1,696 TV series in 2004 with known settings. 601 of them were set in California, that's 35%. 412 in New York, that's 24%. 683 in all other states, that's 40%. We might use a bar chart to display that set of data. One thing I noticed though, if I add up the numbers, the proportions, I get 0.99. Is that a mistake? What happened to the other 1%? Why is it not appropriate to use this information to draw conclusions about a larger population in 2004? Well, I'm not worried about the numbers adding up to only 0.99 because that's only coming about because of round-off error, which will happen pretty frequently when you have 3 or more possible responses. It's not appropriate to use this information to draw conclusions about a larger population because this is the population. Notice the word all in the question. This is covering every TV series in 2004. You might say, well, maybe this is a different population, a population of all TV series ever. But if that were the case, then our sampling frame would be incorrect because our sample is only coming from one particular year. It does not represent the population as a whole. Let's take a look at another example. In a study of 20 Antarctic prions, which are a type of bird, 17 correctly chose one of 2 bags that had previously contained their mate. How will we denote the sample and population proportions? Are those statistics or parameters? Well, the proportion, 17 out of 20, or 0.85, is a statistic because it comes from a sample, and we'll denote it with p hat. The population proportion, which we don't know in this case, would be denoted with p, a parameter. Let's look at a few more definitions. The mode is the most common value that's seen in a set of data. We can talk about the mode for both a categorical variable and a quantitative variable. A majority is the more common of 2 possible values. In that case, it's the same as the mode. The minority would be the less common of 2 possible values. If we have more than 2 possible values, and the mode fails to reach the level where it would be a majority, which would be a proportion of 0.5 or 50%, we use the word plurality to denote that value. Let's talk a bit about sample size to review a bit. In our same study that we've been talking about with the Antarctic prions, would we be more convinced that a majority of all prions would choose correctly if 170 out of 200 chose correctly? Notice 170 out of 200 is the same proportion as 17 out of 20. Remember that in general, the larger the sample size, the more confident we can be with our results. So yes, as long as the sampling and study design are correct, we would be more convinced with this larger sample size. Let's talk about the design of this study involving the Antarctic prions. To decide whether they had correctly chosen the bag that had contained their mate, the prions were presented with a Y-shaped maze with a bag at the end of each arm. One of the bags had previously contained their mate, and the other one hadn't. The prion would enter from the bottom, and then would go down one hallway or the other toward one of the bags or the other. The researchers noted which was chosen. What were the researchers trying to show? Well, they wanted to try to see if prions would recognize their mate by smell. Why use bags and not the birds themselves? Well, if we're aiming to decide if the birds recognize their mate by smell, if they could see their mate at the end of the hallway, they might follow that one based on sight. Why do we say had contained the mate and the bird not being in the bag any longer? Well, if the bird is still in the bag, maybe and that's the mate bird, remember, maybe the bird that we're testing might be listening for the mate down the hall. Since one bag will have contained the mate in the past and the other not, is it okay to always place the correct bag on the right? Well, no. Maybe these prions have some sort of ingrained preference for going right rather than left whenever they're presented with a decision to which they have no preference. Because of this, we need to make sure that the location of the bag that did contain the mate is randomized. Maybe we'll flip a coin for each trial. As for the bag that did not contain the mate, should it just be a plain old empty bag? Well, we have to be careful to make sure that there's no other thing that distinguishes that bag from the other one, except that the other one had contained the prion's mate. So the other bag should have previously contained a prion as well, just a different one from the mate of the bird we're testing. All of these things are important in avoiding bias in the design of the study. Since 85% of the birds chose the bag that had previously contained their mate, that's pretty strong evidence, at least it seems like it. Later on, we'll use the techniques of statistical inference to decide exactly how strong that data set is. When we get on into later sections of the book, in order to keep things simple, most of the categorical variables we will talk about will just have two possible outcomes, a yes or no kind of question. Still, it's worthwhile to know how to summarize and display categorical data when there are more than two possible outcomes. A bar graph is frequently used to display data for a single categorical variable when there's more than one possible response. The bar graph can display counts, percents, or proportions for the various possible outcomes, which are marked on the horizontal or x-axis. And the heights correspond to the count, percent, or proportion. Now those heights, it turns out, it doesn't matter which of those you choose. The heights relative to the other bars will always be the same. Let's look at an example. The instructor of our statistics classes at a big university asked on the survey to report which year they were in college, first year, second year, third year, fourth year, or other. How do we display this information? What can we learn from the display? Well, we would use a bar graph. The years, those are the possible responses, are going to go on the horizontal axis. The counts or the proportions will determine the height. The tallest bar, which corresponds to the mode, will tell you which of those responses was most common. By comparing the heights of all 5 bars, we can see which of them, relatively speaking, were more popular than others. And here are the responses. We can see that the mode is year 2, second year students, by quite a bit. The response of third year came next. First year and fourth year were approximately the same, and other brought up the rear. Let's go back to Excel to learn how to make a bar chart like the one we just saw. Again, we'll use the student survey data, and looking across at the different responses, I see year is given here in column N. So once again, I'm going to isolate the data by clicking on the column header on the N to select everything, and I'll copy it. This time I'll do it by right-clicking and selecting copy. And now I'll click the plus to add a new sheet, and right-click and paste. Now we have our data isolated. Now we need to know the counts so that we can determine the heights of our bars in our bar graph. To do that, we'll need to insert a pivot table. Now the nice thing about these pivot tables is, notice that my data are still all selected over here under A. So if while that is selected, I click Pivot Table. The selection will automatically go into the table range option here, so I don't need to do anything with changing that. I do want to paste this table in our existing worksheet, so I'll select Existing Worksheet, I'll click in Location, I'll click the box over here so I can choose a cell, maybe C3. I'll expand the dialog again and click OK, and we're ready to go with our pivot table. Again, year is the only thing we're looking at, so I'm going to take year, I'm going to drag it over here to the rows, and notice all the possible responses are listed here: 1, 2, 3, 4, and other. Again, I don't need the blank, so I'm going to click on the little arrow beside year, and I'm going to uncheck blank and click OK. And now we need the values here, so I'm going to click on year again and drag it over to the value fields. And now we've got our counts. To get our bar chart, I'm going to select the whole thing. I'm going to go to Insert. Up here I see a bar chart. I'm going to click there. I'm going to take just the regular one here. You can choose any of the others if you want. And I'll make it nice and big so we can see what's going on. But there is our bar chart. One thing we have to be careful about when we're looking at our categorical variables, if we have more than one of them, we have to be aware of the fact that they might overlap. When we're doing probability later on, being able to determine whether there is overlap between our categories will be extremely important. Let's look at an example of these overlapping categories. A report by ResumeDoctor.com that considered over 160,000 resumes found that 13% said the applicant had communication skills, while 7% said the applicant was a team player. Can we conclude that 20% claimed one or the other? After all, 20% is what we get when we add 13% to 7%. Well, the answer is no. If you add the 13% and the 7%, people who had both listed on their resume would get counted twice. This is something we'll learn how to deal with later on. Now, I have shown you how to handle data when we have a very big set. If you've got a small data set, it would be useful to be able to, for you to be able to handle these without relying on software. After all, this is what we're going to be doing on exams. Let's look at an example. A Harvard study claimed that 44% of college students are binge drinkers. A sample of 66 students self-report on at least one occasion in the past month for males were more than 5 alcoholic drinks consumed, or 4 for females, which is the definition of binge drinking in the Harvard study. Of the 66 students, here are the responses. The question is, are the data that we have collected consistent with the claim of 44%? Well, let's go through and count the yeses. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 yeses. It's 28 out of 66, which is 42%. That's pretty close to the 44% that the study claimed, so I would say that our sample looks pretty consistent with the results of that study. Now, our 42% was very close to the 44%, but there is still a difference. How different would that sample percentage have to be in order for you to fall on the other side of the line, to say that actually our sample, and therefore our population, is different from the one that Harvard studied? This is a question that we'll look at very closely when we talk about inference. To summarize, here's what we considered today. We looked at displaying single categorical variables using a pie chart or a bar graph. We talked about how to summarize the single categorical variable using the count, percent, or the proportion. We talked a little bit about biased and unbiased data sampling, whether the sample is representative of the population. We talked a bit about survey design, and we looked ahead a bit at what we're going to be talking about when we talk about inference in this situation. We defined mode and majority, and we mentioned that larger samples tend to give us more confidence when we are making or drawing conclusions. Finally, we looked at how to handle the situation where there are two or more possible responses for a single categorical variable. We looked at the situation where categories overlap, and we talked about how to handle raw data using either a spreadsheet or doing it by hand.